That is first one, find the value of minus 1 by 3 whole to the power of 5 overall divided by minus 1 by 3 whole to the power of 3. Then the second one is express 144 divided by 169 in exponential notation or index form. Exponential notation or in other words it will be called as index form. Now the solution starts now. So solution for the first one is of, so here 1 by 3 whole power 5 divided by 1 by 3 minus 1 by 3 minus 1 by 3 whole power 5 divided by minus 1 by 3 whole power 3 is given first. Then now that equals to minus 1 by 3 whole power 5 overall divided by minus 1 by 3 whole to power 3, then that is equals to minus 1 by 3 must be repeated 5 times. So minus 1 by 3 into 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 minus 1 by 3. So here minus 1 by 3 is multiplied 5 times, 5 number of times overall divided by, now same minus 1 by 3 must be repeated 3 number of times into minus 1 by 3 into minus 1 by 3. Since the operation is of into in between, so we can multiply, so we can cancel up minus 1 by 3 and minus 1 by 3 in the numerator. Similarly minus 1 by 3 in the denominator and minus 1 by 3 in the numerator, and one more minus 1 by 3 in the denominator and one more minus 1 by 3 in the numerator can be gets cancelled. So only minus 1 by 3 into one more minus 1 by 3 is left over, then that is equals to minus of minus is of plus. Let us multiply the numerator separately. 1 1 is of 1 divided by 3 is of 9. So in this manner I say I got the result. Therefore the solution is equals to, so here in this manner we got the solution is equals to, so here just 1 by 9. So this is the first solution. Then now as the second solution. Now in the second solution, solution number 2, we have to express, so here 144 divided by 169, so it must be expressed in exponential notation. So here this is given for us. So here that implies 144 can be written as 12 into 12, its value is of 144. Similarly 169 can be written as 13 into 13, 12 12 is of 144 and 13 13 is of 169. So here 12 is repeated twice, so it can be written as 12 whole to the power of 2 divided by 13 is repeated twice, it can be written as 13 whole to the power of 2. But overall, so here numerator 12 repeated 2 times and 13 denominator 13 repeated 2 times. Overall I mean the exponents are of 2 and 2. Let us write the whole exponent as what I say here 2, and the bases are of 12 in the numerator and denominator is of 13. Here I utilize one identity, that is a by b whole power m can be written as a power m divided by b power m. Here the exponents are same, so I wrote I say here exponent as single whole power m, and I wrote the bases as a by divided by b. Similarly here also 12 square and 13 square, so here exponents are same just as m and m, so I wrote the same m as the single exponent. Here I said 2 as the single exponent and as a and b as a divided by b, 12 and 13 as 12 divided by 13. Then now, so here example number 2, in the similar manner let us perform the example number 2. So here in this example let us simplify number 1 as 5 power 3 into 5 power 4, and the second problem as 3 power 4 whole power 2, and the third problem 5 power 7 divided by 5 power 2, as the fourth problem 1024 whole to the power of 0.4. Solution number 1, here in this first solution, that is 5 power 3 into 5 power 4 is given for us. So in this manner I say here, because this is similar to the first loss of indices, that is a power m into a power n, that is equals to, since bases are equal and the symbol in between is of into, we can add up the exponents, that is a to the power of m plus n. So similarly, so here we can write 5 to the power of 3 into 5 to the power of 4. A value is of 5, a is equals to 5 and m value is of 3. and n is of 4. By substituting here, we can write as 5 into a into a power m into a power n as a power m plus n. Here a value is of 5 to the power of m plus n, that is 3 and 4. So one is of 3, the other is of 4. So we can write it as 3 plus 4, that equals to 5 to the power of 3 plus 4 is of 7. So in this manner I got, so here therefore 5 to the power of 3 into 5 to the power of 4 is equals to 5 to the power of 7 as the result. The second one is of 3 power 4 whole power 2. Now the second one is of second solution. Three power 4 whole power 2. Then now it is similar to the identity, that is a power m whole power n is equals to a power m must be multiplied with n. So here mn, so this is our second identity. Based upon this identity, so here a value is of, so the problem is of 3 power 4 but whole power 2. Then now by comparing we get a as, so here the base a is of 3, then now here m is equals to 4 and n is equals to 2. So here based upon these values we can write the resultant as a is equals to 3 to the power of m into n. So here 4 into 2, so here 4.2, then that is equals to 3 to the power of 4 2 is of 8. So in this manner I say I got, therefore so 3 to the power of 4 whole to the power of 2 can be written as 3 to the power of 8. Then our next solution, that is solution number 3, as 5 to the power of 7 divided by 5 to the power of 2. So here we can utilize one identity, a power m divided by a power n. The condition is here m is greater than n is equals to a power m minus n. By utilizing this condition, so we can write it as, so here that implies 5 power 7 divided by 5 power 2, whereas here 7 is greater than 2. So we can write it as so here a as 5 and m as 7 and n as 2, whereas a is of 5. Then now that is equals to a to the power of m minus n, a is of 5, so here m minus n, that is equals to 7 minus 2. Then that is equals to 5 to the power of 7 minus 2 is of 5, because so 7 is of positive sign and 2 is of negative sign, plus into minus is of minus, so we have to subtract 7 minus 2 is of 5. 7 is greater than 2, 7 sign is of positive sign, so it will be plus 5. So in this manner I say I got, so here therefore 5 to the power of 7 overall divided by 5 to the power of 2 is equals to 5 to the power of 5 is the resultant. Then now the fourth one, solution number 4, that is 1024 whole to the power of 0.4. So that implies, so 1024 written as it is, but whole to the power of 0.4. In order to remove the decimal, I am going to multiply with 10 and divide with 10 immediately, because after the decimal there is only single digit. You have to multiply with single 0 followed by 1, that is 10, and immediately divide with 10. So here that is equals to, or that implies 1024 whole to the power of, so here when we multiply 0.4 with 10, when we cancel up 1 0, then the decimal after one digit will be gone off. Then we will get as only just 4 in the numerator divided by 10 in the denominator. But let us write, I say here, let us take the LCM and let us write the factors. So prime factors of 1024. So here, so in a rough work I say 1024 can be written as, so here 2 5s is 10, then 2 1s is of 2, 2 2s is of 4. Then now with 2 2s is of 4, carry 11, so 2 5s is of 10, carry 12, 2 6 is of 12, 2 1s is of 2, 2 2s is 4, 1 is left over, that is 16, 2 8s are 16. Then now 2 6 is of 12, then 2 4s is of 8, 2 3s is of 6, then 2 2s is of 4. Then now 2 1s is of 2, 1 is left over, carry, that is 12, 12 6 is of 12. Then now 2 8s is of 16, then now 2 4s is of 8, then now 2 2s is of 4, then now 2 1s is of 2. So in this manner I say I got 1024 as, so 2 multiplied 1 2 3 4 5 6 7 8 9 10, so it can be written as 2 raised to the power of 10. Instead of 1024 we can write it as 2 raised to the power of 10. So we can show it as the rough work column. Then later, So that implies this 1024 within the bracket can be written as 2 power 10, 2 raised to the power of 10, but over to the overall whole to the power of 4 by 10 is there. So now that implies a to the power of m whole to the power of n type, so it can be written as 2 to the power of m into, that is bracket indicates into 4 by 10. So here I have utilized one identity, that is a to the power of m whole to the power of n is equals to a to the power of m into n type. So this identity I have utilized. Based upon this identity, so I wrote 2 to the power of 10 into 4 by 10, but denominator 10 and here numerator 10 gets cancels, that implies 2 to the power of just 4 is left over. So here 2 must be repeated 4 times, that is equals to, that implies 2 into 2 into 2 into 2. So when 2 is multiplied 1, 2, 3, 4 times, so 1, 2, 3, 4 times, its value is of 16. So here that implies 16. So in this manner I say here, therefore, so 1024 whole to the power of 0.4 is equals to just 16. So in the similar manner, let us perform the one more example, that is example number 3. So in this example number 3, simplify a to the power of p minus q into a to the power of q minus r into a to the power of r minus p. So we have to simplify a to the power of p minus q dot into a power q minus r into a power r minus p. So now the solution starts. A power p minus q into a power q minus r into a power r minus p is given for us. Then now that implies, so here bases are same, a and the symbol is of into in between. We can write as we can add up all the exponents. So here p minus q plus q minus r plus r minus p. Since, so here it is, the reason is of a power m into a power n into a power p is equals to, since bases are equal and the symbol is of into in between, we have to add up the exponents, that is a power. So here m plus n plus p. So based upon this identity, so here bases are same. So I have added the exponents, I mean p minus q, q minus r and r minus p. So that implies a to the power of, by removing the brackets, so p minus q plus q minus r plus r minus p, because before this bracket is there a positive sign, need not to change the signs. Whereas here also before this bracket q minus r there is of positive, so need not to change the signs, and p is of positive and here p is of negative, we can cancel up. Minus q and plus q also will be gets cancels, and minus r and plus r also will be gets cancels. Then that implies a to the power of nothing is left over in the, as in the exponent. So as the exponent, therefore a to the power of 0 will be written as 1. Since what I say, the identity is of a power 0, whose value is equals to 1. Anything raised to the power of 0 equals to 1. So hence a to the power of p minus q into a to the power of q minus r into a to the power of r minus p's value is equals to, so 1.